to introduction to straight lines. When we talk about straight lines, it's not just lines, but how lines relate with positions. Now, before we start talking about straight lines and details and analysis, let's first of all talk about points and position first. Now, in coordinate geometry, you understand that a particular point is always denoted as xy. That xy denotation is that the x is called x-axis and the is called y-axis. But one thing is, it can also be called abscissa, and this is called ordinates. You can call it abscissa, you can call this ordinates, but just basically simply call them x-axis and y-axis. But these position points we're talking about can be used to analyze straight lines. For example, I take something of this nature. I can tell you there's a straight line, and this straight line is at, maybe this A and this is B, but this B is at X, probably this one is at X1, Y1, X1, Y1, and this X2, Y2. X always comes before Y. If I do this, it is the reason for this is because where it stops ends here, it can be located down, and this can be located down. You discover that this came first, that's x1, and this one that came as x2. If you locate it down to this point too, this is y1, the least, and this one that locates here is y2. So it makes it easy. So from here, I can take out some values from here. I can operate out some values from here. The first thing I can get from here is something I call, the first thing I can get, number one, take note of this please. The first thing I'll get from here is called distance between 2 points. Distance between 2 points. Let me get the distance between 2 points. The distance between 2 points here is given as point A and point B. The distance between these 2 points is given as x2 minus x1 squared plus y2 minus y1 squared. I can have that as distance between 2 points. There's something else I can get from here. I can get a thing called this gradient or slope of a line or of a line. Good. Now, its flexibility. The slope, the gradient is all about the flexibility. The datities of the line. The datities of the line. That's what it means. The datities of the line. Flexibility of the line. Now, from there, I can say that the gradient represented as n is y2 minus y1 over x2 minus x1. So you take 2 notes. The first note is the distance between 2 points. The distance between 2 points is x2 minus x1, y2 minus y1. Don't forget that I square there. And you have the gradient or slope of a line. Is m equal to basic. So from here, I can bring out my analysis based on the fact that I can take calculations on this. So first of all, let's start with distance between 2 points. I can take values like, on top of that, I can even have something from here. The third thing I can have from here is that if you look at this, you observe that angle theta can be observed here. And don't forget, if you have angle theta here, m can also be tan theta. So always remember something. that the gradient of a line can also be tan theta. The gradient of a line can also be tan theta. What it means is that y2 minus y1 can also be equals to tan theta. It's still the same thing. The reason is because tan is opposite over adjacent, and this opposite here is y2 minus y1, and here is x2 minus x1. So opposite over adjacent will give us y2 minus y1 divided by x1, which is also tan of theta. So always remember, the gradient of a line, as far as angles are concerned, is the same value as tan theta. And the gradient of a line is y2 minus y1 over x2. And the distance between 2 points can be x2 minus x1 into bracket square plus y2 minus y1 square. Now let's take this. For questions, if for example I'm asked to find the distance between 4,3 and 1,5. Let's start with this. Solution to this is simple. You can have something of this nature. The distance between these 2 points, probably this is point Q and this is point R. So QR will give me square root of x2 minus x1 all squared plus y2 minus y1 all squared. But the question is this: how do I know my x2? How do I know my x1? That becomes very simple. Your x2, your x1 is simple. If I take this value, for example, this value is 4, 3. So, and I know it is xy. So the first one will be assumed to be x1, y1. The second will be x2, y2. So I'll take this as x1 and I'll take this as y1. So now from here, what do? I will have x2 is 1. So that is 1 minus xy, which is 4, all squared, plus y2 is 5 minus 3 x2. So from here, that's minus 3 squared, the square root of 9. Well, this 5 minus that's 2. 2 squared is 4. So we have square root of 13. So that's the answer for the value of distance between 2 points. So always remember, the distance between 2 points is calculated using the formula there. Now, we're done with that. So we cannot see question relating to gradient of a line. But funny enough, the gradient of a line is also something. If, for example, you are asked to find the gradient between these 2 points, 4, 1, the gradient of 4, 1, 6, 8. What do? M is the gradient. It can also be called what? Slope. So gradient is y2 minus y1 over x2 minus x1. But funny enough, where is x1? This is x1, y1, x2, y2. So my y2 is 8 minus y1 is 1. And my x2 is 6 and the other is what? 4. So what do I have? 8 minus 1 is 7. That is 2. So probably if I have something like this, 7 divided by 2, many times should I go? That's 3. So that's 3 over number 1 over 2. So please, the gradient is 3 over number 1 over 2. So anytime you're having gradient, remember the formula to calculate the gradient of 2 points or a line. Now, we're done with that. Let's now consider something else. We're still on introduction to straight lines. So let's consider something else. Let's talk about the thing which is the most important thing in this topic, straight lines. It is called the equation of a straight line. Now, equations of a straight line. these equations, they are of different types. I can consider equations depending on where the slope or the gradient manipulation stays. But some of the most important ones are there. We have the intercept form. Let's see this first one. The first one we're going to consider. Maybe you have something like this. You have something like this, and there's a line. This place here where it stops is C. So the gradient of this kind of line, you observe that gradient of this kind of line can be manipulated down to this. So if you look at this value here is X, and this value here is Y. So if you want to operate it yourself, not to forget, I prefer deduction. Good. If you want to operate this not to forget, this is why it is there. So if you look at it, you can tell yourself, and there is no value of x1 or x2 because from here it is 0. So you can just tell yourself, okay, intercept form. For the intercept form, what do? I will just tell you gradient m is what? Is change in y over change in x. All the change in y, change in m means is y2 minus y1, x2 minus x1. That's the change. So from here, I can just tell you that m now is, what's the y2? These values is this minus this. This highest y, this is the lowest y. So you have y minus c. So down here, you have x minus 0. The reason is because there is no other value. It did not touch the x-axis again. So from here, I can have, if you take it from here now, you discover that what you're having is x minus 0 is x. So you have mx is equals to y minus c. So if you move c there, you have mx plus c equals to y. So y is mx plus c. So this is the first equation. It's called the intercept form. So always remember this, that this is the intercept form. So if you have this in the back of your mind, so automatically if you're having y equals to mx plus c, and you are asked to find, maybe you are given an example where you are given a gradient m to be equals to 2, and you have your gradient as 2, and you have your intercept c as 2 over 3. So how do you find the equation? The equation becomes y equals to 2x plus 2 over 3. So if you multiply all through by 3, multiply by 3, you have 3y. Multiply this by 3, you have 6x. Multiply this by 3, you have 2. So that is the equation. So it's easy. Always remember, the first equation is y equals to mx plus c. Now we're done with that. We'll now consider another one, which is the 1.4. This is the intercept. Not intercepts, just intercept. Intercept form. Then we have the 1-point form, we have the 2-point form, so on and so forth. So now let's consider the other one, which is the 1-point form. Now 1.4. Now for the 1-point form, it's easy. All you just need to understand is that the gradient is given as y minus y1 is equals to m into bracket x minus x1. So always remember this. This is a very important equation. So y minus y1 equals m into bracket. So this equation can also be rewritten as y minus y1 is equals to tan theta x minus x1. The reason is because, if you remember, I told you that tan theta is still the value of m. So m replace it, it's still the same thing. So from there, if you are given an example, for example, you are told to find the equation for a 1-point form, and so maybe you are given, okay, maybe find the equation of a line which passes through 4, 3 and has gradient 6. Okay, that will just become y minus y1 equals to m x minus x1. The reason why I know is this is because it passes through just one point. This is the point, pass just one point. So because it passed 1 point, I'm good. So that will give me y minus, and this y1, x1, y1. That y1 is 3, m is 6, you have x, that will give us, x1 is 4. So if you do this, it becomes easy to say minus 3 equals to 6 times that is 6x. That will be 24. So from there, if you take your values out, from here, if you bring this value, you can decide to say y is equals to 6x minus 24 plus 3. Depends on how you want your equation to stay. Depends on you. So y is equals to, except you are running an objective analysis or the objective. So depend on how the answer is. So you are done with that. So you have 6x minus 24 plus 3. That will become minus 21. So that is the equation. So that's for 1 point form. Always remember, the reason why I did that was because it passes through 4 points. Beautiful. And that's that. Oh, let's consider the 2 point form. The 2 point form is something that is a little bit interesting. The interesting side of the 2 point form is that the 2 point form is just a deduction from the 1 point. Recall, please. Recall that the 1 point, y minus y1 is mx minus x1. And because of that, it shows that if you divide here with this and divide both sides, m now becomes x minus x1. I mean from this equation, divided by y minus y1. But also recall that what? M itself is y2 minus y1 over x2 minus x1. If you remember that. So if m is this, and these two equations, they are the same, and this is m, so you can just replace it, this m here. So if you do that, automatically that will give you something else, and that thing will become, you just discover that m now is something else. M becomes y2 minus y1 over x2 minus x1, which is equals to this now. What's that? That's x minus x1 over y minus y1. So this is the 2 point form. So anytime you're dealing with the 2 points, you have questions that have to do with 2 point form. And again, you can also have the intersects. That's the difference. There's S here. Intersects form. It states that 1 is equals to x over a plus y over b, where a and b are the intercepts. They're the intercepts. So always remember that you have things like this that are the intercept. And let me see whether I can take this question on that. For example, you have something like this. Maybe at this point you have 0, 4, and here you have 3, 0. If you have something like this, just like your work, you will discover that if I want to find the equation, we'll have 1 is equals to x over a plus y over b. So the one on y is b, and the one on x axis is a. So what do? I'll just say 1 is equals to x over a. This is a on x axis 3, and y, the one on y axis, that's 4. So what's the LCM? The LCM is 12. Multiply here by 12, that will be 12. Multiply by 12, that will be 4x. Multiply by 12, that will be 3y. So the equation is this for this. So now, that's that. So you've been able to understand how this works. So we have the intercept form, the 2 point from the 1 point, the intercept form, and so on. Now, the general form of the equation itself is simple and easy to understand. The general form, the general form itself is ax plus by plus c is equals to 0. That's the general form of every straight line equation. Every straight line equation must obey this. That's the general form of every straight line equation. Okay, that's good. But in the other way, we can consider other situations. We can consider other situations in the sense that other situations how you can have equations of this form. You can have now lines basically do obey some conditions. These conditions, as far as straight lines is concerned, is that either it obeys perpendicular condition or it obeys parallel condition. So a straight line can be perpendicular. You can say perpendicularity, the condition for perpendicularity and the condition for parallelism. So there are conditions for perpendicularity, there are conditions for parallelism. So equations, we treat that out for us. It makes it easy. Now, basically, I can put this out by saying that if a line does not intersect, a parallel line basically does not intersect. They just move. The parallel lines never meet. They just go. But perpendicular lines do intersect. That's why when somebody say that a person is parallel to success, what does that mean? It means that the person can never ever meet success. So parallel lines never meet. So look at this. In context, condition for parallel. For parallelism states that M1 is equals to M2, meaning gradient 1 is always equals to gradient 2 for two lines that are parallel. But for perpendicularity, it's a different thing. M1, M2 is equals to minus 1. This is the condition. Please, M1, M2 equals to minus 1. So when they tell you this line is perpendicular, this is the condition for perpendicularity, and that's the condition for parallelism. Now, the truth is, when I'm giving an equation, for example, let me see, I can take an equation from here. If I take an equation, for example, maybe I'm asked to find the equation of the line. Find the equation of the line. Find the equation of the line. Which is parallel to 2x plus 4y equals to 6 and passes through 2, 1. So we are looking for the other line, but the one of the line we know has this equation, but we're looking for the other line. Immediately we get the other line, it passes through this. So it's easy to find. The reason is because When you see those conditions, you just first of all bring out the equation 2x. What's the other thing? 4y. The other thing is what? Is 6. Then you arrange it to be y equals to mx plus c. Arrange it like this, so that you follow mx plus c. Immediately you arrange it. Let's arrange. Y come first. You should remember that y equals to. So if I arrange that, I'll have 4y equals to minus 2x plus 6. 6 is settled there. It's not moving. So it's plus 6 there. So if I divide both sides by 4, I'll have y equals to minus 2 over 4 plus 6 over 4. So y now is minus 1 over 2 plus 2. Oh, sorry, that should be 3 over 2. So, sorry, there's x, there's x. If you look at this equation and this equation, what's the value of n? If you consider it, consider these two equations. Now you observe that y is there, the c is 3 over 2, but n is equals to minus 1 over 2. And this n is m1. But what's the condition for this? They said that they are parallel. That's the thing, it's parallel. So because it's parallel, m2 is also equals to minus 1 over 2. Because condition for parallelism states that m1 is equal to m2. So simple enough, I have that. So I'll now bring out my values by saying that now m is known. The m2, which is the second equation that I'm looking for. We already know the first one, given. The second equation we're looking for is m2, and it has a value minus 1 over 2. But it passes through one point. What is the point? 2, 1. Because it's 1 point, what formula will you use? Y minus y1 equals to m into bracket x minus x1. So that gives us y minus, what's y1? y1 from 2, 1, that's 1. And m is minus 1 over 2, and that will be x minus 2. Yeah. So, if you multiply the whole of this, first of all, let's just complete that. You just take the 2 across. So that will be 2y minus 2 equals to minus x plus 2. Use the minus 1 to open after the 2 has gone across. Computation. So what do you get here? So you have 2y. You take the 2 across. When you take the 2 across, you bring the plus x equals to 2 plus 2. So 2y plus x is equals to 4. That's the equation. So basically, now you see that the condition here was because it's parallel. But what about if it's perpendicular? You can still obtain that for perpendicularity. M2, M1 equals to minus 1. Okay, that's that. But basically we can see something else from here. We can consider that there are some cases where you have lines intersecting. Lines can intersect each other. They can rub minds. So when they intersect, when they rub minds, and have something of that nature. So let's do that. If they intersect, what are you going to have? Probably you have this. Maybe a line moves like this, another line moves like this. What do? They intersect. And yes, they intersect. Lines can intersect. But basically, for two intersecting lines, for two intersecting lines, for you to obtain the gradient of two intersecting lines, it's better for you to solve their equations simultaneously. That is far better. You solve them simultaneously. So because of that, it's easy for us to say this line is this and that line is that. But sometimes there's an angle between them. You can always find the angle between them, which is you have specialties, and you have the specialties. So exterior angles, interior angles. So the angle between them, you can always have that as maybe alpha. Maybe this theta 1, theta 2, and so on. But basically, you have to solve, if the equation of this is given and the equation of this is given, to obtain the gradient, you solve them together. So now, it's easy. It's easy to say, okay, the first value for this, let's try and see if your equations, let's try this. Let's see this from now. Let's take this from now. Find the equation of a straight line. Let's take this one now. Example, find the equation of a straight line, the line of the straight line which passes through the intersection of x plus y is equals to 3 and x plus 2y is equal to 5 and has a gradient of 2. You can see how simple this is. So you just solve them out. How do you do that? First of all, you start. There are two equations. Just solve them simultaneously. X plus y is equals to 3. X plus 2y is equals to the other one is you have x plus y is 3, x plus 2y is equals to 5. So if you look at it, since these two values are the same, just subtract the equation. This will cancel this. So y minus 2y is equals to 3 minus 5. Mathematics. So y minus 2y, that will be minus y is equals to minus 2. So because of that, y is equals to 2. That's the first thing. So put y equals to 2 into the first equation. The first equation is x plus y equals to 3. So you have x plus 2 equals to 3. So x is 3 minus 2. So x is what? 1. Good. So automatically you have x is this x. So now you have x is 3 minus 2. So that's 1. So automatically that one is settled. So the points now where they are is 1, 2. So their point is 1, 2, and it has a gradient of 2. So if you are given a point 1, 2, and you have a gradient 2, which of the formula we use for the equation y minus y1 equals to m 2 bracket x minus x1. That's for 1 point because it's just 1 point. So you have y minus, what's y1 again? y1 is 2, m is 2, x minus 1. So that will give us y minus 2 is 2x minus 2. So what do you get there? You move, this will cancel this because they are both minus. So y is equals to 2x. That's the equation. So class, that's simple enough. So but sometimes you can apply your basic straight line principles in business. How can you do that actually? It's possible. You can use that for businesses, and anytime you're giving calculations that has to do with that, it's all about intersection. Because when plotting your demand curve and price analysis in your economical factories, you can have things like a general function question. Function for quantity and price is given as Q is equals to MP plus C. I think you should use this. This should be okay. So, if for this quantity demanded, this is price, and that's the price, and that's the intercept of your curve line. So with this, when the first thing you need to do is to find the intercept and M. These are given. For example, you are given this as quantity demanded is 300 naira, and the price, okay, sorry, quantity demanded is 400 pieces, and price is 300 naira. You have quantity. When the quantity is the higher the quantity demanded, the higher the price. So from here, if you have this as 300, probably your price is like probably the price is 240. So you can place this into this equation. First of all, the Q, that's when it's 400. But yeah, it's just an assumption that you have 300 M plus C. The second one will be 300 is equal to 240 M plus C. So this is equation 1 and this is equation 2. With this, after solving, you have the value for M and C. And whoever you want to determine, you can determine this value. And I think I've been able to talk a little about introduction to straight lines. This will be the end of this class. I remain your math instructor. Thank you. We'll meet in other classes.